Hey guys, my name is Mauricio Crispim, and in today's video, we will introduce you to the Duct Calculation Android application. This is a completely free application that can be of great use to you, especially when you're in the field and need to calculate the pressure loss in an air conditioning duct network. As we mentioned previously, it is designed for Android and therefore works on any cell phone of this type. So let's go to our video. If you like it, be sure to like and subscribe to the channel, and we will continue to bring you quality content. So the first step is to download the Air Duct Calculation app from the Play Store. As I said, this application is only available for Android, but even so, I believe it will be very useful for you. Once installed, you will open the application, and here on the home screen, you can select the units, which can be the International Metric System in centimeters, International Metric System in millimeters or English, or American System in inches. Most of the time when we talk about ducts in Brazil, we talk in centimeters, so let's put them in centimeters. Here we have the calculation of rectangular ducts, calculation of circular ducts, and the program instructions. So calculation of rectangular ducts, you have here the input data, which are 3, also needs the calculation for the singularities existing throughout the Ducts network. So here we have it for curve, knee, for S, for T, which would be branching, for reduction, extension, or transformation from rectangular to circular. So let's calculate a small network of ducts that I showed here, that I already left here, that we even presented in another example. It is initial duct that is feeding inner diffuser, with the first section leaking 1920, 1440, 960, and 480 cubic meters. Let's put my duct height, that is measurement B. I'll want it to be 25 centimeters, so B equals 25 centimeters, okay? And let's once again put that tip about our pressure loss. It has to be 0.5 pascals per meter, which is equivalent to 0.5 millimeters of water column per meter. Okay, so let's go to the first section of 3 from 1920. Here in the program, we have 3 pieces of data. You can enter with measurement A, measurement B, the mass flow, and it will give you the result of velocity and pressure loss. Let's take a guess here. Let's put 50 centimeters at the height of duct 25, and my first flow 1920 m per hour.
Okay.
And I'll have it calculated. It gave a speed of 5.27 m per second and a pressure loss of 0.98 pascals per meter. I said that I wanted a maximum pressure loss of 0.5 pascal per meter. So what do? I'm going to exclude this measurement A. I could increase it, make interpolations, unmark it here, and now here I'm going to put the desired pressure loss. So I'm going to put my desired pressure loss here of 0.5 pascals per meter. I'll have it calculated. So we found a duct measuring 71 centimeters by 25. I'm not going to make a duct measuring 71 centimeters. I'm going to make a duct measuring 70 centimeters. Just to confirm, it was 0.51 pascals per meter, which is great. So let's go. My duct here will be 70 by 25. My second excerpt then, let's say here that I want a loss of pressure. 5, that my breakout here is 1440.
140.
1440.
140.
Okay. And I'll have it calculated.
Não, 25.
25 here. 25. Leave this measurement here blank, 0.5 Pascal per meter, and I'll have it calculated. So it gave me a duct measuring 52 by 25. So I'll put that, this one will be 52 centimeters if I don't make a duct. So I'll put it here that it's 50 for 25.
The
third section, I go here, take this measurement here again, 960, okay, pressure drop of 0.5. Let's go. We calculated the duct was 37 by 25. I'm going to make the duct here 40 by 25. And the last section, which is a section of 480 cubic meters, cubic meters, I leave it blank here. I have it calculated. So it was a duct measuring 25 by 25, 25 by 25, that's it. Quickly, this here, as I told you, could even be done in the field. We calculated our duct network here with the first section of 70 by 25, the second of 50 by 25, the third of 40 by 25, and finally 25 by 25. It is also a useful program, for example, also to calculate knees. In this case, first we put it here. You could enter, for example, a 90-degree angle. Dimension A, for example, 50 centimeters. Dimension B, for example, 20 centimeters with a radius of 15 centimeters. Okay, a flow of 500 cubic meters. And I have it calculated. It was just right up to a loss in the singularity of a loss of 0.5 Pascal. Okay, so it's a simple program. You have to make the results obtained here very clear. They are not that accurate, but now the program overestimates the loss a little. So I make it a little higher. And this will not cause you any problems. Quite the contrary, you will be protected. This program here will not make you choose a fan with insufficient static pressure. Quite the opposite. The program here will be serving you in a practical and simple way for some situations, mainly residential applications or things like that. Okay, so that's what the fray. We had shown this program. Okay, this is the application we wanted to present. I hope you liked it. I'm sure it will be very useful, and I'll ask you again. Did you like it? Like, subscribe to the channel, share with your colleagues, okay? And we will continue to bring you quality content. Until the next video.